Good morning, my dear friends. See now, so now on this elastic shortening, we'll try to solve some problems now. So now this first problem, I will read it now. A straight pre-tensioned concrete member, 12 meter long, okay, with a cross section of 400 mm wide and 500 mm depth, is concentrically pre-stressed with 1000 mm square steel wires. So now, in sense, the cable, in sense, now the span of the beam he has given, it is 12 meter, and its cross section is 400 mm by 500 mm, and he says that it is pre-stressed with 1000 mm square steel wires, okay, which are kept concentrically. Concentrically means there is no eccentricity. They are in the sense CGC and CGS are both are same. Okay, which are anchored to bulkheads with a stress of 1000 Newton per mm square. Okay, so this is the pre-stress in the cable. If ES, in sense Young's modulus of steel is so much and EC is so much, he has given both the values ES and EC. Okay, compute the loss of pre-stress due to elastic shortening. Okay, so now you have to find out the elastic shortening loss. So the problem is very simple. So now the loss of pre-stress due to elastic shortening, as we have seen, it is given by delta Fs is equal to m into P naught by AC. Okay, where m is, it is the modular ratio. Modular ratio is given by ES by EC. Am I right now? ES is the ES value also he has given. EC value also he has given. So ES by EC, if I do it, it will give me 6. So now I came to know the value of m. So now P naught by AC I have to now calculate. Okay. See now. Now P naught is the initial pre-stressing force. Okay. AC is the area of the cross section. Area of the cross section also you know. Area of cross section he has given in the problem as 400 mm by 500 mm. Am I right, sir? No. So concrete area AC can be now easily calculated. It is 400 mm by 500 mm square. So answer is this. Okay. So now initial pre-stress he has given. Okay, it is 1000 Newton per mm square. Okay. So now this can be converted into initial pre-stressing force. I want to now calculate it now. Okay, so initial pre-stressing force P naught can be calculated as now, it is 1000 is the pre-stress into area of steel. Okay, so stress into area will give me the force. Okay, so both values you know, so I can easily calculate the initial pre-stressing force. So P naught also I came to know. So now in this equation, P naught is known, AC is known, M is known. Okay, so you can easily calculate the loss of pre-stress as delta Fs as so much. So if you put the values, you will get 30 Newton per m square. Or the percentage loss of pre-stress can be now easily calculated. 30 is the loss. This is going to occur when you apply a pre-stress of 1000 Newton per m square into 100. So it will give me 3% as the loss. So now it's a very simple this thing now problem. So we'll go to the next problem. See now, second problem says, I will just read the problem now. Second problem, a pre-tensioned concrete beam 100 mm wide and 300 mm deep is pre-stressed by straight wires carrying an initial force of 150 kilonewton at an eccentricity of 50 mm. Okay, see now the cable has been now placed at an eccentricity of 50 mm here. Now he has given the cross-sectional area of this beam 100 mm by 300 mm, and the cable has been now placed at an eccentricity of 50 mm. Okay, below the CGC. Okay, 50 mm. The modulus of elasticity of steel and concrete are 210 and 35 kilonewton per mm square. In a sense, ES he has given, EC he has given. Okay, respectively. Okay, estimate the percentage loss of pre-stress in steel due to elastic deformation of concrete if the area of wire is 188 mm square. He has given the area of the wire AS. Okay, so now solution we'll see now. P now he has given the pre-stressing force as 150 kilonewton, otherwise it is 150 into 1000 newtons. It is the initial pre-stressing force. Okay, eccentricity he has given 50 mm. Area of concrete you can easily calculate. Moment of inertia also you can calculate. It is BDQ by 12. Okay. Now since you know ES and EC, you can easily calculate the modular ratio M also. Okay. It is ES by EC. So it will give me 6. So but now the problem is, now the cable is laid at an eccentricity. Am I right, sir? Now in the last problem the cable was concentrically pre-stressed, in the sense E was 0. But now E value is 50 mm. Am I right, sir? Now, so now I want to calculate the stress in concrete at the CG of the steel. In the sense, at this level, wherever the cable is there, at that level, I want the stress in concrete. So now it can be now easily calculated. It is a P by AC plus PEY by I, where Y value is now E. In the sense, if I come down by a distance y, I will reach the CGS. Am I right, sir? Now, so CGS I will reach after traveling by a distance of 50 mm. So y becomes 50 here now. Okay, at y is equal to E. So now P you know, okay, AC you know values, P again you know. Eccentricity is now as usual, it is minus 50 because it is below CGC, and y value is now, okay, y is at a distance of 50 mm, and since again it is below CGC, again I have to assign minus sign. Okay, divided by I know, I can easily instance. So now it will give me FC value in sense of stress in concrete at the level of CGS is 6.66 Newton per mm square. Okay, so now I can easily now calculate the loss of pre-stress due to the elastic deformation. As you know, it is given by M into P naught by AC or M into FC, or stress in concrete. So M I know and stress in concrete I know. So now it will give me around 40 Newton per mm square. Okay, so this is the loss due to elastic shortening. So now initial pre-stress I can easily calculate. It is the pre-stressing force divided by area of steel. Both I know. Pre-stressing force also I know. Area of steel also I know. So it will give me 798 Newton per mm square as initial pre-stress. So now I think I can easily calculate the percentage loss of pre-stress. Okay, this is the loss. 40 Newton per mm square is the loss. This loss has taken place when you apply 798 Newton per mm square pre-stress. Okay, into 100. So it will give me around 5% as the loss. Okay, so now whenever there is some eccentricity in the cable, okay, this point you have to remember. In the sense, you have to calculate the in the sense now stress in concrete at the level of that steel. At the level of that steel, you have to calculate the FC value. Okay, so you can easily calculate this loss due to elastic shortening. Okay, thank you very much.